Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of peanuts in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of peanuts in any step at all? That's the challenge. If you'd like to accept it, pause the video and work it out. Now, this pattern is very similar to one we saw just a couple of days ago. We started with 1 peanut, we went to 6. I think the same thing is going on here. Yeah, and we came up with this linear equation of y equals 5x minus 4. Take a look at this one. Do you think we're going to come up with something pretty similar? Is this going to be another linear equation? Is it the same equation? Or is it something else? What do you think? Well, I think the way I'm going to approach this one is just to look at how much we're adding. On that last pattern, we started with 1, and then we added 5 to get to 6. So this is plus 5 between the two steps. And then here, what have we got? 6, 12, 13. So to get from 6 to 13, you actually have to add 7. So we didn't add 5 that time. And in fact, we added 2 more than we did the step before. So if we were going to follow that pattern to get to step 4, I would add 9. So adding 5, then 7, then 9. And 13 plus 9 would be 22. So I'm going to say 22 peanuts in step 4. Now, just looking at this, can you make a prediction about what kind of pattern this is? Is this linear? Is it quadratic? Is it something else? And how can you tell? Well, I'm going to go ahead and put the numbers in a chart, although we've got what we need right now to know what kind of a pattern this is. But I'm going to go ahead and chart them up. So we'll make the step number and the number of peanuts. So in step 1, we've got 1. In 2, we've got 6. In 3, we've got 13. And in 4, we're seeing 22. And if we subtract 6 minus 1 is 5, 13 minus 6 is 7, 22 minus 13 is 9, 5, 7, and 9. Those numbers should look familiar, right? They're what we were adding each step, so that's what the difference is between each step. And it's not a constant, so this can't be a linear pattern. Even though it's very close, it looks very similar to that linear pattern we did a couple of days ago. This one's not. If we take the difference of the differences, 7 minus 5 is 2, and 9 minus 7 is 2, we do find a constant. So that means this is quadratic, and our leading term is x squared. So x squared what? I mean, in step 1, x squared works, right? But in step 2, well, x squared would be 4, and there's 2 more. So how can that possibly be? And then in step 3, 9. So actually, let's do that. Let's mark off the squared part. So there's all of it that is the 1 squared, and there's the 2 squared. Let's do 3 squared. So we would need 9. These aren't arranged really well to make it easy to mark off 9, not in a square anyway, but there's 9. So that's 3 squared. So we've got 4 left over. So what does this mean? We've got 0, really, and then 2 left over, and then 4 left over. So whatever comes after the x squared, the leftovers, has to satisfy this sort of progression of 0, then 2, then 4. What you should notice is that this goes up by 2 every turn. So this is actually going to be 2x. And then to make it work in step 1, if we put in a 1 for x, that would be 2 times 1 is 2. And that's 2 too many because we need 0. So we actually have to subtract away again 2. So this part of the equation is going to be 2x minus 2. It's just this leftover part that I'm working on here. So let's try that in step 2. In step 2, it would be 2 times 2 minus 2. 4 minus 2 is 2. That's how many are left over there. How about in step 3? 2 times 3 minus 2. 2 times 3 is 6 minus 2 is 4. That's how many are left over there. So we've got our squared part, and then we add in 2x, but then we subtract another 2. So that is not an easy equation to get to. But now that we've got it, y equals x squared plus 2x minus 2, it's pretty easy to get the number in step 43. We're just going to plug in 43 for x. So y equals 43 squared plus 2 times 43 minus 2. What is that? 1849, and then plus 86, and then minus 2. So let's see, is that 1933, I think? So in step 43, there should be 1,933 peanuts. Well, how did that go for you? I think that was a pretty difficult one. And it looks very similar to this one here, but the equations are very different. Well, let me know how that went. Thanks, everybody.